Okay, let's wrap up our discussion of experiment design. Here are the objectives for this lesson. You might want to pause this again while you copy down these objectives. You're also going to want to grab your textbook because I'm going to refer back to a bunch of examples in the book. So, copy down the objectives, grab your textbook, and then hit play again when you're ready to move on. All right, moving on. We understand that these randomized comparative experiments that we're working on depend on our ability to treat all of the experimental units exactly the same way, except for the actual treatments being compared. So we're going to talk about some ways now in which you might be able to refine these designs a little bit. The first way in which we might try to make these experiments better is by using what's called a double blind. In a double blind experiment, neither the subjects nor the people who have contact with them know which treatment a subject received. So neither the subject knows which treatment they received, nor the people who are working directly with the subject know which treatment that subject received. For example, if we think back to our pharmaceutical company where we're developing the drug to cure the common cold, the subjects don't know whether they're actually getting the true drug or if they're getting a placebo. And maybe the technicians who are working with the subjects, helping measure symptoms, don't know which treatment they received either, because their responses might be biased if they already knew which treatment the subjects received. Now, someone behind the curtain, so to speak, has to have a list of which subject received which treatment so they can make a comparison of these results. But the idea is that the subjects don't know who they're working with, and the people who are working directly don't know who they're working with. They don't know which treatment the subjects received. Something else that you have to be cautious of is what's called a lack of realism. Your experiment should be as realistic to your what you're trying to design as much as possible. I would take a moment and read examples 5.14 and 5.15 in your book. Now, these comparative randomized designs that we were just looking at, they're pretty simple. We can do better, though. We can do some more elaborate statistical designs. And one of those is what's called a matched pairs design. So, yep, we're picking it up a notch. Matched pairs designs have some important characteristics. First, we're just comparing two treatments, and only two treatments. Next, we want pairs of experimental units that are as alike as possible. Because the idea is we have a pair in our matched pairs design, we have a pair of subjects that are as alike as possible. We're going to give one of them one of the treatments and the other one the other treatment. And these subjects are supposed to be so alike that the only difference between them is the treatment that they're receiving. Another way of doing that is having each subject serve as their own matched pair. So each subject would get both treatments, one right after the other. Now remember, we need to have randomization. So because the order of the treatments might influence our response. So we want to randomize the order for each subject. Maybe we flip a coin or roll a die, pick random numbers, some way of determining which treatment is received first. An example of a matched pairs design might be a taste test of which one do you like better, Coca-Cola or Pepsi. So what you might do is have each subject serve as their own matched pair, such that the order in which they receive the two treatments is randomized. Maybe you flip a coin. If it's heads, the person gets Coke and then Pepsi. If it's tails, they get Pepsi and then Coke. Everything else is going to be the same. We're going to make our comparisons within each of these matched pairs. A good example in the textbook of a matched pairs design is example 5.16. I do want you to recognize that when you're describing a matched pairs design, you're not going to use a diagram like we did for the comparative randomized designs. What you're going to do to describe your matched pairs design is just write out a paragraph, making sure you hit all the important parts. Make sure you describe how you're going to do your comparison, how you're going to do your randomization, do you have replication. Make sure you describe your response variable. Now, and where'd my notes go? Hold on. All right, let's try that again. The idea of matched pairs is they reduce the effective variation. Our subjects, our groups are as alike as possible other than the treatment being received. But matched pairs are simply just an example of what's called a block design. In a block design, a block is a group of experimental units or subjects that are similar in some way that is expected to affect our response to our treatments. When we do a block design, we divide our subjects up into their blocks, then we carry out the assignment of our subjects to the treatments separately within each block. Let me show you an example. And the example I'm going to use is example 5.17 on page 302. Now, what they've done, and this is the way we're going to diagram out these block designs, we are going to use a diagram, but it's going to be a little bit different. We're going to have all our subjects, and we're going to divide them up into two blocks. One block might be all the men, and the other block might be all the women, because maybe we have an idea ahead of time that men and women are going to respond differently to, what is this about, some type of cancer therapy. So once we have divided our subjects into blocks, we do our random assignment within each of those blocks. We might have three groups, group 1, group 2, and group 3 for the men. And whatever the treatments are, we'll just call it treatment 1, treatment 2, and treatment 3. Maybe we have 3 treatments. We're going to do the same thing for the women. We're going to divide them up into 3 groups, group 1, group 2, and group 3. And we will assign the same 3 treatments to the women. And then we're going to make our comparison separately within each block. So it looks like here we're comparing some type of survival rate. So we'll do that for the men, and we'll do it for the women. We're going to do it separately within each block because our goal is we wanted to eliminate men and women as lurking variables. We want to eliminate gender as a lurking variable. So if I determine which treatment is better for the men and which treatment is better for the women, we're going to do that separately so we can eliminate that as a lurking variable. Okay? And that's that. Thank you.